In this video, we'll look at the transformations of an exponential. I recommend watching some of the other transformations videos first. Nonetheless, let's get started. The equation is y equals 3 times 2 to the power of a quarter x minus 2, and all that's in the exponent, plus 5. Well, the first thing you should know to do is before you even get started, we have to common factor this exponent. So here's a 2 down here, and I'm going to common factor out a quarter from this exponent. And the reason is that'll show me the transformations properly. I pull out a quarter from a quarter x, I'm obviously left with x. A lot of students get confused here. What's negative 2 divided by a quarter? Well, you could just ask your calculator, or you could ask, what do I put here so that when I were to rainbow this 1/4 back in, I'd get negative 2? And the answer is minus 8. And see that? If you were to put this 1/4 back in, you'd get 1/4 x, and then a quarter times negative 8, which is negative 2. So I've correctly common factored this exponent, and now I can start to do transformations of an exponential. I'm going to use the mapping rule. The mapping rule starts by making a table of values, and this is my original table. I usually just write orig, and you can see the table's parent function by getting rid of all the transformations. This 3, this quarter, this minus 8, this plus 5. Do you see that the original function was just y equals 2 as the base to the power of x? That's what I'm going to start with here, the original table of the parent function. So if it helps you, what I'm looking at is y equals 2 to the power of x, but you don't have to write that. And so I can sub it into my calculator, do it in my head. What's 2 to the power of 0? 1. What's 2 to the power of 1? 2. What's 2 to the power of 2? 4. 2 to the power of 3? 8. And that should help you if you aren't as good with negative exponents. What's 2 to the power of negative 1? 0.5. I just do the same pattern that I see here. What's 2 to the power of negative 2? 0.25. And again, if you don't believe me, you can ask your calculator. What's 2 to the power of negative 2? 0.25. So mapping rule starts with an original table, and then we're going to actually write down the mapping rule. The mapping rule looks like this. It's a recipe for points. So write x comma y, it's always x comma y, and an arrow. X comma y says all your points in the form x comma y go to these new points with the following recipe. Let's look at the x transformations first. There's a quarter here on the x's, and whatever you're doing to the x, you do the opposite. So here you see a quarter, or divide by 4. That means we times all the x's by 4. Again, do the opposite of what you see, which is divide by 4. So we times all the x's by 4, and then we see minus 8. So we're going to plus 8 on all the x's. What do we do for the y values? We take all the y values and we times them by 3, and then we add 5. That's our recipe for our new function that you see here based on the original parent, 2 to the power of x. So now I get my new table. It's nice if you put arrows here for the reader saying go to there, and then after the mapping rule, here's my new table. I usually start with the y values because they're typically easier to do. What's 3y plus 5? Look at the y column. I'm going to do them all together. What's 3 times 0.25 plus 5? And you get 5.75. You can do it in your head if you want. Won't judge you if you use a calculator. What's 3 times 0.5? I'm just going down in order, applying this part of the mapping rule. 3 times 0.5, oops, plus 5. And I get 6.5. Now I could probably do it in my head. What's 3 times 1 plus 5? 8. What's 3 times 2? 6. Plus 5. 11. What's 3 times 4? 12. Plus 5. 17. And what's 3 times 8? 24. Plus 5 gives 29. Now I'm going to do the x values, which in this case actually aren't that hard. What's 4 times negative 2? Negative 8 plus 8 gives 0. What's 4 times negative 1? Negative 4 plus 8 gives 4. And you can see a pattern developing here. What's 4 times 0 plus 8? 8. I bet you can predict the next one. It's 4 times 1, 4, plus 8 is 12. What's 4 times 2? 8, plus 8 is 16. And what's 4 times 3? 12, plus 8 is 20. And so now I've got my table. The mapping rule has helped me make a recipe to make a table of values for this equation very quickly. Now I just have to graph. Well, graphing with me always works the same sort of way. You start with a x-axis and a y-axis. Make sure you label them. I don't like the way the arrow looks. Let's fix that. Here's my y-axis with a much nicer arrow. And now I'll make the x-axis. Always put your arrows, always label x-axis, y-axis. And now I need to make a scale. My scale's got to go as high as 29 on the y's and as high as 20 on the x's. And just keep that in mind as I'm making these ticks here. Make sure to label at least every second tick. Right now I'm just going to put them down. And remember, I got to go up to 20 and 30. We'll see what this will look like. Though you should already have some idea, if you understand exponentials, what an exponential will look like. Particularly this one. I know it's exponential growth. Yeah, it's been transformed a lot. But that shouldn't change the general shape. An exponential growth equation. It's been moved around and stretched. Okay, I had to get up to 20 on x, so I think I'm going to go up by 10. So that'll be a 10, that'll be 20, that'll be 30. And then that makes this negative 10, negative 20, negative 30, though I won't use that much. And for y, I got to get up to 29, so let's go up by 10 as well. That's 10, that's 20, that's 30, that's negative 10. Make sure to actually show the ticks and also label at least every second tick. And now let's put our points. Start at 0 for x. You're at 5.75, just above the 5 here. At 4 on x, so that's just before the 5, you're at 6.5. At 8 on x, you go up to 8 on y. At 12 on x, you go up to 11 on the y. At 16 on x, you're at 17 on y. It's about here. And then at 20 on x, you're at 29 on the y. That looks about there. You know what exponentials look like, and there it is, the perfect shape of exponential growth. So connect all your points nicely in a nice smooth curve. Try not to make any particular segment straight. Should all curve together. And it goes on forever in both directions, so make sure to put an arrow, even onto the negative side here, and onto the positive side. And there you have it. We've graphed an exponential using its transformations. How? We first common factored out the quarter, and then we did the original table, the mapping rule, and then the new table, and we used that information to graph.